Hi class, in today's video we'll discuss about rational and irrational numbers. We'll look at what is rational numbers, how to represent rational numbers on number line. We'll look at some of the properties of rational numbers, okay, how to insert rational numbers between two given rational numbers, what is irrational numbers, how to represent irrational numbers on the number line, and few theorems on irrational numbers. So let's get started. So let us see what is rational numbers. Very easy. A number which can be written in the form P by Q, where definitely Q not equal to 0 because something divided by 0 is undefined, and PQ belongs to integer. That is known as a rational number. For example, if you see minus half, 3 by 2, or even 0, because 0 we can write as 0 by 1, 5 we can write 5 by 1, suppose 19 by 5. These are all my rational numbers. Now rational numbers are expressed, we just did, P by Q, where PQ belongs to integer and Q definitely not equal to 0, and PQ are co-prime, which means they have no common factor except 1. Just see this one. Look at this. Suppose I say half, I say 8 by 16, I say suppose 20 by 40, suppose I say 64 by 128. Now look at all these. These are all equivalent rational numbers, which means 8 by 16, 20 by 40, 64 by 128 are all expressed as 1 by 2 on the number line. So whenever you are expressing a rational number, see that they are co-prime. The numerator and the denominator, P and Q, should be co-prime to each other. They have no common factor except 1. Now we have already done how to represent a rational number on a number line in previous classes. How to represent a fraction on a number line we have done. For example, see, representation of rational number on number line. I'll show you few examples. Suppose 1 by 2, or suppose 3 by 2, suppose 5 by 3, suppose minus 4 by 3. These numbers, how to represent? We know. I'll draw a number line. Suppose this is my 0, this is 1, this is 2, this is minus 1, equidistance minus 2. Half lies between 0 and 1 in the midway, which means 0 and 1 I'll divide into 2 parts, and this will be my half. 3 by 2 is 1.5. Again, 3 by 2 lies between 1 and 2. Am I clear or no? Which means between a 1 and 2, 1.5 again, half, which means I'll divide this into 2 parts, and this is my 3 by 2. Okay, 5 by 2. 5 by 2 means, look over here, 1, 2 by 3, which means this lies again between 1 and 2. 2 by 3. 2 by 3 means between 1 and 2, we'll divide it into 3 parts, and the second part is 1, 2 by 3, which means suppose the entire thing over here, look at this, we'll divide into 3 parts. 1, 2, 3. See? 3 equal parts. Then this part is your 5 by 3, isn't it? Minus 4 by 3. Minus 4 by 3 means minus 1 by 3. which means it lies between -1 and -2. This is what, suppose we write in mixed fraction, though we don't write generally. Okay, 1/3, which means we divide this into 3 parts. See, and the first part is this one. Am I clear? So this is how we represent a rational number on the number line. We can represent all rational number on the number line. Now let us see few properties of rational numbers. Properties. The first one, if A is your rational number, B is your rational number, when you add them, you get a rational number, isn't it? Similarly, A minus B, again, if A is a rational number, B is a rational number, you'll still get a rational number. Similar is the case with multiplication, division also. Of course, B not equal to 0, isn't it? Which means all the operation, which is addition, subtraction, multiplication and division, are closed in rational numbers. Am I clear? Which means the resultant is a rational numbers. Then this is interesting. Rational numbers are ordered. What do I mean by that? Suppose you take 2 rational numbers, then 3 cases will arise. First one will be greater than the second one, or the first one has to be the less than the second one, or it could be equal. The 2 of them will be equal. This is trichotomy. Is it clear? They are ordered. You can compare them. And last thing, between 2 rational numbers, suppose A and B, we can insert as many rational numbers as possible. I can insert one rational numbers between A and B. If A and B are rational numbers, I can insert 2, which means in the number line, if you have A and B, then there are infinite rational numbers between them. Is it clear? We'll see how to insert rational numbers between 2 given numbers, okay? Between 2 given rational numbers. Let us see the exercise, which is totally based on inserting rational number between 2 given rational numbers. Now look at exercise 1.1 from Aggarwal, which is totally based on inserting rational numbers between 2 given rational numbers. Okay, first see number 2. Insert 2 rational numbers between 1/3 and 1/4 and arrange in ascending order. First of all, check out which is the bigger number, which is the smaller number. We know how to check 1/3 and 1/4. So this comes 4 and 3. So 4 is greater than 3, which means 1/3 is greater than 1/4, which means 1/4 and 1/3. How do I insert a number between them? Just find the average. How do you find the average? This is the first number I've inserted. You add the 2 and divide by 2. So that's 12. That's 3 plus 4/2. That's 7/24. So what happens? This becomes 1/4, 7/24 and 1/3. Now I'll add one more number between these 2 numbers. Same, I'll find the average. Second number, see, 1/4 plus 7/24/2. So 24. This is 6 plus 7/2. That's how much? That's 13/48. Which means your numbers are 1/4, 13/48, then 7/24 and 1/3. So I inserted 2 rational number between 2 given rational number and arrange them in ascending order. Am I clear? Just finding the average. Similarly over here you see insert two rational numbers between minus 1 by 3 and minus 1 by 2. Same way, first I'll check which one is the bigger one and which one is the smaller one. So minus 2 and minus 3, which means minus 1 by 3 is greater than minus 1 by 2, which means minus 1 by 2 is less and minus 1 by 3 is a bigger number. What I'll do, I'll first insert between these two. I know how to insert. I'll just find the average. See, minus half minus 1 by 3 by 2. You take LCM, that's minus 3 minus 2 by 2, which means minus 5 by 12, which means between these two I can write minus half minus 5 by 12 minus 1 by 3. Then I'll insert a number over here. You can insert over here also, your wish. Answers can be different, okay? So your second number is, you add the 2 and then divide by 2. So that's how much? 12 is LCM, minus 6 minus 5 by 2. So that's minus 11 by 24, which means your answer will be minus half. Then you inserted a number between them, which is minus 11 by 24. Then you inserted minus 5 by 12, minus 1 by 3, and they are arranged also. Am I clear? In ascending order. So this is your answer. So this was the average way. You just add the 2 and divide by 2. You will get the number between those two given numbers. But suppose, look over here, you have to find 5 rational numbers between 3 by 5 and 4 by 5. Again, the average method is time consuming. So what we'll do, if you have to add more numbers, 1 or 2 numbers, average method is okay. But 5, 10 numbers will follow another way. What is that? See, they have told 5 numbers, no? So 5 plus 1 is 6. First of all, see that the numbers which are given should be in like fraction, which means the denominator will be same. If not same, make it same. Over here it was same. What we'll do, look carefully, 3 by 5 and 4 by 5. They said insert 5 numbers. So 5 plus 1 is 6. You multiply the numerator and denominator, both the rational numbers, with 6. So 3 multiplied by 6, 5 multiplied by 6 becomes 18 by 30. Similarly, 4 multiplied by 6 and 5 multiplied by 6 becomes 24 by 30. Now between 18 and 24, which numbers are there? There's 19 by 30. There is 20 by 30, 21 by 30, 22 by 30 and 23 by 30. See, I successfully inserted 5 numbers between them. Now we should cancel this. See, this should be co-prime. I told you earlier. This is 2 by 3. 3 7 times, 10 times, 2 11 times, 2 15 times, and this. So these are my 5 numbers between 3 by 5 and 4 by 5. Look at one more sum. Find 10 rational numbers between minus 2 by 5 and 1 by 7. The process is same. First change it to like fraction, which means the denominator should be same. So minus 2 by 5 and 1 by 7. We know how to change it to like fraction. Okay, this one multiplied by 5 and this one multiplied by 7. So it's minus 14 by 35, and this is 5 by 35. Now between minus 14 and 5 there are so many numbers, they have told us to find 10. So this will be minus 13 by 35, minus 12 by 35, minus 11 by 35, minus 10 by 35, then minus 9 by 35, minus 8 by 35, minus 7 by 35, minus 6 by 35, 8 minus 5 by 35, this is the ninth one, minus 4 by 35. So these are my 10 numbers. Now I'll reduce it wherever possible. This as it is, this as it is. Don't leave the answer over here, okay? We'll reduce it. This is minus 2 by 7. This is minus 9 by 35 as it is, minus 8 by 35, minus 1 by 5. This is minus 6 by 35. This is minus 1 by 7, and this is minus 4 by 35. So I've added 10 numbers between those two given numbers. You can choose any way. When you have to find less numbers, when you have to add less numbers between them, use the average method. But when it is more, 5, 10, then use this method. Am I clear? Now let us see irrational numbers. Now let us see what is irrational numbers. Definitely which cannot be expressed. The numbers which cannot be expressed in the form P by Q, where Q not equal to 0 and PQ belongs to integer and PQ are co-prime to each other. So if you cannot express a number in the form P by Q, then it is known as irrational numbers. The Pythagorean, which means the people who follow Pythagoras, they were the first to discover this kind of numbers. Examples, the root of a number which is not a perfect square is always an irrational number. For example, if you see root 2, root 3, I'm not talking about root 4 because root 4 is a perfect square of 2, root 5, root 6, these are all your irrational numbers. Even you can say non-terminating, non-recurring decimals. They are also your irrational number because they cannot be expressed in the form P by Q. For example, if you take 0.10, 100, 1000, 1000, dot. So these are all your examples of irrational number. Now the question arises, how to place root 2, root 3, root 5 on the number line, because this cannot be expressed in the P by Q form. Over here we take the help of Pythagoras theorem. Look how. Suppose I want to represent, root 2 and root 3 on the number line. How do you proceed? See. Now suppose this is your number line. This is suppose 0. This is 1, which means this is 1 unit. The length is 1 unit, 1 centimeter maybe, okay? This is 2. Now look over here. If I draw a perpendicular over here, and the line segment is again 1 unit, okay? Then, if you look carefully, this A, B, C is your right angle triangle, which means the hypotenuse will be, this is 1 unit, okay? This is 1 unit. The hypotenuse will be the square of the base plus the square of the perpendicular. Okay, so that's root 2. So this length is what? Root 2. We can easily measure this length OA with the compass. Place your compass over here and cut an arc. See, root 2 is 1.414 roughly, close value. It goes on, okay? So over here somewhere you'll get root 2. Similarly, if I want to find root 3. Now already I know root 2. From here to here the length is root 2 unit. Okay, so if I draw a perpendicular over there, okay, of again I'll draw 1 unit of this. Okay, then suppose this is OPQ. Then again, what is OP? OP will be root of the base square plus the perpendicular square, which is root of 2 plus 1, which is root 3. Okay, roughly we know root 3 is 1.732. So measure OP with the compass. Place your compass over here. Place your pencil at P. That will be the length OP. So cut over here. Measure the length OP. At O you place the compass and cut a point over here. Suppose this is R. So this will be your root 3. Am I clear? Like this way we can represent irrational numbers on a number line. Now let us see two very important properties before we look at the sums from this exercise. First of all, if A is any natural number, P is any prime number, and if P divides A square, it simply means P divides A. For example, see, 2 divides 10 square, isn't it? Which means, can we write 2 divides 10? We can write. Am I clear or not? Next, if A, B are two natural number and P suppose divides AB, it simply means P divides A or P divides B or P divides both A and B. Am I clear? These two properties will use to prove that a given number is an irrational number by contradiction method. Am I clear? Let's see sums from the exercise based on this. Look at exercise 1.2, the first sum. Prove that root 5 is an irrational number. Okay, we have to prove it by contradiction method. Remember that. Contradiction method. Don't prove it by division method. You are finding the square root of root 5 by the division method. Remember? Don't do it by this method. We'll do it by contradiction method. What is contradiction method? We'll assume root 5 as a rational number and proceed. And we'll see that at the end our assumption is wrong. We contradict our statement, okay? Which means it will not be a rational number. That simply means it is an irrational number. Am I clear? Just look how I'll do it. Let root 5 be a rational number. Suppose we assume, okay, then we can write root 5 as P by Q, where Q definitely not equal to 0 and P and Q are integer, and the most important part, PQ are co-prime, which means no common factor except 1. Remember this is very important, okay? Now let us see. Squaring both sides, we'll do squaring both sides. So it becomes 5 equals to P square by Q square, which means, can I write P square equals to 5Q square, which means P square is a multiple of 5, which means 5 divides P square. 5 is a prime number. We just did the theorem. So if a prime number divides A square, then that prime number divides A also, which means 5 divides P also, isn't it? So let us take P as 5k. We can assume where k is an integer, where k is your integer, then put the value of P equals to 5k over here. What will get? Look over here. 5k whole square is equal to 5q square, which means 25k square equals to 5q square, which means 5k square equals to q square, which means q square is a multiple of 5, which means 5 divides q square, which means again 5 is a prime number, so 5 divides q. Look carefully, 5 divides q and 5 divides p, which means 5 is a common factor between p and q, but according to our assumption they are co-prime, there's no common factor, which means our assumption is wrong, which implies our assumption is wrong, which means your root 5 is an irrational number. Proof. Always prove by contradiction method. Clear? Now let us look at the next sum. Now look at sum number 6, which says prove that root 2 is an irrational number, hence show that 3 minus root 2 is an irrational number. First of all, we'll prove root 2 is an irrational number by contradiction method. We know how to do. Let root 2 be a rational number, which means root 2 can be written as p by q, where definitely q not equal to 0. pq belongs to integer and pq are co-prime, which means there is no common factor except 1. Now look, squaring both sides, what do you get? 2 equals to p square by q square, which means I can write p square equals to 2q square, which means p square is a multiple of 2, which means 2 divides p square. Now 2 is a prime number, so we can say 2 divides p also. Remember this. So we can take p as 2k, where k is an integer. We can represent because p is a multiple of 2. Okay. Now put p equals 2k over here. So we get 2k whole square equals to 2q square, which means 4k square equals to 2q square, which means q square, if you look carefully, is equal to 2k square, which means q square is a multiple of 2, which means 2 divides q square. Now again, 2 is a prime number, so 2 divides q also. So we are getting 2 as a common factor between p and q, but according to our assumption they don't have any common factor, which means our assumption is wrong, which means root 2 is an irrational number. Done. Now let us see the second part, which says hence show that 3 minus root 2 is an irrational number. Very easy. By contradiction method. Let 3 minus root 2 is equal to r, where r is your rational number. Then we can write 3 plus r equals to root 2. Now look carefully. R is a rational number we have taken, which means 3 plus r is also a rational number, which means according to this statement root 2 is a rational number, which contradicts our statement because we already know that root 2 is an irrational number. which contradicts our statement, isn't it? Which means 3 minus root 2 is an irrational number. Very simple. Clear? Now let us look at the next sum. Now look at the last sum for exercise 1.2. Prove that root 2 plus root 5 is an irrational number. Again, by contradiction we'll prove. Let root 2 plus root 5 be a rational number represented by r. So we can say root 2 plus root 5 equals to r, which means, can I write root 5 is equal to r minus root 2? Squaring both sides, can I write root 5 square equals to r minus root 2 square, which is 5 equals to, this is a square plus b square minus twice a b. Am I clear? Which means 5 minus 2 is 3 minus r square is equal to minus 2 root 2r, which means I can say 2 root 2r equals to, r square minus 3, which means I can say root 2 equals to r square minus 3 by 2r. Now look carefully. We have already taken r is a rational number, which means r square is a rational number, no doubt in that. Which means r square minus 3 is a rational number, because 3 is a rational number, which means r square minus 3 by 2r is a rational number, which gives us root 2 is a rational number, which is contradictory, because we already know root 2 is an irrational number. We already know, which means it contradicts our statement. Contradicts our statement, which means we can say that root 2 plus root 5 is an irrational number. Done. So this was the last sum for this exercise. There are few more things to be discussed in rational and irrational numbers. We'll discuss it in the next video. Till then, take care.